I want to go over a couple different examples of solving radical equations. And I think everyone's pretty much okay with these first two kinds, right? We have a square root of x equal to 6, and you should feel comfortable with saying that the opposite operation of a square root would be squaring. And so you would just square both sides of this equation and get x equals 36. Now it's important to check your answers when dealing with radical equations because occasionally there is an extraneous solution, which would be basically solving the equation correctly, but the answer doesn't really work, because really an answer to an equation is something that you can plug in and get the make sure that the equation is balanced. So just as a quick check, we'll say, well, is the square root of 36, is that really 6? And that is true, so we do know that is the answer. And so just the same way for this second equation, we still have the square root, so we're going to do the opposite operation. So we're going to square both sides of this equation. And we'll have 2x plus 1 equaling 9. Subtract the 1, 2x equals 8. Divide by 2, and x equals 4. And again, we're going to plug that in just to make sure, where we'd have the square root of 2 times 4 plus 1, and check to see if that's equal to 3. And 2 times 4 is 8, plus 1 is 9, and sure enough that is true. So we're happy so far. Okay, so for this next example, it's just another square root, but you'll notice that we have a couple numbers that are outside of the square root, and your first move should always be to condense these numbers together on one side. You want one of your radicals. If you have more than one, you just want one of them on one side of the equation and everything else on the other side of the equation. So I'm going to start off here by adding 2 to both sides. And so we have 5 equals the square root of 2x minus 7. Now we're allowed to square both of these, both sides of the equation. And we get 25 equals 2x minus 7. Now it's just a simple equation. We'll add 7 to both sides. So we'll get 32 equals 2x. Divide both sides by 2, and x equals 16. Again, you want to check just to make sure. Go back into the original. Right, and you're asking yourself, does 3 equal the square root of 2 times 16 minus 7 minus 2? And to simplify that, you have 3 equals the square root of 32 minus 7 minus 2. And finally, 3 equals the square root of 25, which is 5, minus 2. And so then you should be happy with that one. That would give you 3. Okay, so the basic idea is going to be the same with any radical. Whether you understood this or not while you're doing other square root equations, you're really just raising each side to the reciprocal of the root that you were given. Okay, and so for this next equation here, you should see that we're dealing with a cube root now. So we're going to treat it a little bit differently, but essentially it's going to be the same idea. But just to illustrate it, I'm going to first change this into its exponential form. So this is x to the 1/3 power equaling -4. And what we're going to do is think of a number we can raise this exponent to so that it is a whole number, and ideally that whole number being 1. Okay, so and then once we decide that, we're going to raise both sides of the equation to that. And so I would say that you know, if you remember your exponent rules, right, you're really asking yourself what times 1/3 gives you 1. And so that should be 3, or 3 over 1. And so then we're going to raise both sides to 3. And I'm going to kind of write this out in the long way so you can see it. This would become x to the 3 over 3. And this would become negative 64. So that would be x to the first equaling negative 64. And if we go back to check that, you would say, is the cube root of negative 64 equal to negative 4? And it sure is. So we can use the idea that we used on the previous example to solve any radical of any root. Okay, so now we have the fourth root. Again, we want to get everything that's outside of that radical to the opposite side of the equation before we get involved with the radical itself. So I'm going to start off by subtracting 11. So then we have the fourth root of 3x minus 5 equaling 7. Again, I'm going to change this so you can see where I'm coming up with this into its exponential form. So this is really 3x minus 5 all raised to the 1/4 power. And again, think to yourself, what do I need to multiply 1/4 by to get it to become 1? Because that's what you're going to do to both sides. So really you're just dealing with the reciprocal here. We're going to raise it to the 4th power, and we have to do that to both sides of the equation. So on the left hand side we're going to have 3x minus 5 to the first power, or 4 over 4, and then we're going to have 2401. Okay, now again it's just like a normal equation. I'm going to add 5 to both sides and get 3x equals 2,406. I'm going to divide 2,406 by 3 and get 802. Okay, and again, you do want to check these just in case it doesn't work. Could be an extraneous solution. So I'm going to go back to the original and plug everything in. We would have the fourth root. Oops, let me write that right. We have the fourth root of 3 times 802 minus 5, and we'll see if that equals 7. So 802 times 3 is 2,406 minus 5. Subtract 5 there, we get the fourth root of 2401, and that does equal 7.